Okay, Christian from Skycatch, Chris Anderson, my good friend from 3D Robotics, come on out. So, Chris, we've known each other a long time. You're formerly the editor of Wired magazine, and you quit your day job of being a magazine editor and getting to just write stories all day and meet interesting people to start a company. That company's 3D Robotics. What do you do?
We make drones. This is one of them, but we're the world's leading open UAV platform. We're the Android of drones. And this is started as a hobby about 6 years ago. I started a website called DIY Drones, sort of realized that the technology inside smartphones, the sensors and the GPS and the radios, et cetera, would also be fantastic for aerial robotics. Started whacking away at it, and a few years later, now we run, among other things, a Tijuana drone factory where this is made.
So you started this adventure. When did you start that DIY Drones website? It feels
2007.
So you've been covering or just geeking out to drones for 7 years.
Yeah.
And you left the greatest job in technology, being the editor of Wired magazine, working for Condé Nast, where they buy you houses in the Hamptons, and you have like
multiple houses
in the Hamptons. And you left that job to start a company to make drones. What is the state of the company? How many people work on it? How many drones do you ship? I mean, just generally broad speaking.
So we have about 180 employees. We raised about 37 million in venture capital. Manufacturing in Tijuana, engineering in San Diego. I'm in the Berkeley office where we do software business. We do sort of tens of thousands. Mostly what we sell are autopilots, which is the brain, if you will. Looks like that. So this is the sensors and the processors and the software. And you put this in any vehicle and it becomes a fully autonomous GPS-guided drone.
Well, there you go. So this is basically, is it like an Arduino, like a computer?
Originally we started with Arduino. This is now a Cortex M4. It's basically a smartphone processor, smartphone sensors, but laid out with the appropriate connectors and software for drones.
Now all these connectors, I see I guess that's telemetry.
Telemetry, GPS, power monitoring, various sensors.
At the heart of this drone technology, what makes this all possible? What was the innovation that made drones go from being just not in people's consciousness? And these are quadcopter drones or copter drones?
These are quadcopters. They also come with 6. It's called a hexacopter, and octocopters are fixed-wing aircraft or even rovers. This is a universal autopilot, does it all. But the enabling technologies were MEM sensors, the gyroscopes, the accelerometers, the magnetometers, the GPS getting very cheap and very good, radio technology. It's basically exactly the same stuff that's in your phone.
So because so many people in the world bought smartphones, that technology became so cheap and so tiny that it could fly.
I call it the peace dividend of the smartphone wars. It's that the economies of scale, the Apples and Googles, made this technology that used to be military industrial, extremely expensive, available for a few bucks at Radio Shack. And then you would combine it with open platforms like Arduino, Raspberry Pi, BeagleBone, and then of course the web, the open innovation community. So this is open source hardware, open source software. We have 50,000 members in the community who collectively build this, and this is the kind of stuff that 10 years ago would have been a $10 million Lockheed product, 5 years ago would have been $1 million, and now it's $750, it's coming to Walmart soon.
Really?
Not really, no.
Well, okay, so in 5 years, though, 10 years, what do you estimate an Iris, which is your latest?
Yeah, this is only released last week, by the way.
Only released last week. What would the Iris cost, in your mind, this equivalent technology, 10 years from now?
$99.
$99. Wow. And I assume by that time, it's going to be even more stable.
It's going to be, so this right now is optimized for a GoPro, and so, thank you. If you, it's got a gimbal on the bottom, and as you can see, as you move it around, the gimbal holds it absolutely stable.
Right.
You get sort of Hollywood quality video from that. It's GPS guided. It's got telemetry, so you can control it with your phone or tablet. Mm-hmm. So those elements right now are really designed for GoPros. As we go forward 5 years, they're going to get much smaller. So this weighs a couple pounds, and you're not going to carry it in your pocket. But there's no reason why, as cameras get better, that can't be something you carry in your pocket.
Let's talk about stability for a second. If one of the copters or rotors goes down, this falls from the sky.
On a quadcopter, it does. But if you want that kind of redundancy, you go to 6 or 8. Once you have 6 or 8 props, then you can lose one. It'll stay in the air.
Can you lose 2?
It depends which two.
Okay. 2 on one side, no. 2 on opposite sides, maybe. So are we going to fly this, actually?
I think we are.
Okay,
yeah.
let's fly this. Who's going to do it?
So my colleague John here is going to. Now, this, by the way, is an open platform. So what I described to you was our software and electronics. We make drones, but we also make it available to anybody else. So, for example, the Pocket drone that you saw yesterday.
Yeah.
Same platform. That's our software. Our electronics as well, and the one that Chris is going to be showing you is also our platform. So again, we use the Android model. This is, in a sense, the Android of drones, and it can be used in any hardware platform.
Got it. And okay, so we're going to see this.
So we're going to see whether we can get the RF. We should be able to kind of broadcast. We may be able to get the broadcast the video as well.
Okay, there it is. We see the video up there. It's perfect.
So
okay,
these props are going to spin up now. That was the arming sound.
And how safe do we feel these are these days?
Well, we're not going to fly it over the audience.
He did yesterday.
Yes.
You don't advise that, huh? Can you bring it down a little lower and closer to us?
So as you can see, John's controlling the gimbal as well.
Yeah. Got it.
So he's looking down there.
Now, if somebody were to touch one of the things, does it recover nicely?
Yeah. John can move it. It's designed to be basically like a camera boom that can go anywhere with that kind of boom level stability.
It makes a bit of noise.
It does.
Is the noise is there a way to mitigate against the noise, or that's just par for the course?
You can use different props, and you can lower it a bit, but ultimately you're blowing air around.
It's gonna be that way. It is fascinating how stable they've become. 3 or 4 years ago, would you have done a demo like this at a conference, or would anybody?
I would have, but I wouldn't have been very smart to do so. It would not have been as reliable, it wouldn't have been as stable, and it wouldn't have had that stabilized gimbal at the bottom either.
Right. That's a key there, is that you're now able to do, and we have a little bit of just fairness to the...
Yeah, so we're actually recording in high def. It's a GoPro, so we're recording in high def, which is perfect.
But the video you're seeing up there, just so people know, when we do show the video, there's a little interference here because of all the Wi-Fi in the audience.
So outdoors, you wouldn't have this RF.
You wouldn't have all that. All right, so what are these going to enable, in your mind? What's the 2 or 3 most important things for society that led you to want to do this?
Well, this is sort of the golden age of photography and video. We basically, with the iPhones in our pocket and the quality of cameras, we have the ability to take Hollywood quality videos of our own lives. We call it the ultimate selfie.
Right.
And as you can see, we now have, for the first time in history, we can see the world from a vantage above eye level. Right. And we can see it in beautiful high def, gorgeously stabilized, as if we had as if we were Steven Spielberg with that kind of quality equipment. So I think creatively, it allows us to visualize our own world from a new vantage. Commercially, this is big data. This can do crop mapping. We have the ability to put sensors in the air, below the level of satellites, above the level of the ground, and we can do it almost for free.
Almost for free. All right, and obviously security is something that people see as a big thing here, and that's where our next company, Skycatch, comes in. So why don't we bring that bad boy in for a landing?
Thanks, John.
It is so impressive how stable they are now.
Yeah.
How long does it take to be good at driving one of these?
Well, ideally, you wouldn't drive this at all. It's fully autonomous. You just what you do is with your app, you just you bring up your app. It shows you where you are, and so the driving process is really just draw a line. Here, let me bring over the camera. Here, I'm just going to sort of say I'd like it to kind of go this path and look at that stuff, and it creates those waypoints. Then you press go. And so that process of just sort of drawing and sort of pointing on the map, drawing a path, and then saying go, no flying skills required. And that's what a drone can do as opposed to an RC copter.
Are they going to eventually be aware of what's around them to do avoidance?
Yeah, so that's the holy grail of this. The next big thing is what's called sense and avoid. So right now, this uses GPS and some sensors, like to know where the ground is. But if there's a tree here, it's going to hit the tree. It doesn't know about that. But you probably saw that Google announced Project Tango.
Yep.
So Project Tango uses Android-like technology to start to do what they call SLAM, simultaneous location mapping, which is essentially when you walk into a building, you have your eyes, and your eyes say, well, there's a wall there, and there's a door there, and you map out and then navigate through this using nothing but your eyes. Project Tango, we worked with them, and our friends from ETH in Zurich, the Technical University in Zurich, also worked with them. And they're using Iris as an aerial SLAM platform to do exactly what you described, sense and avoid, to be able to kind of use the cameras to spot obstacles, to find the right path, and otherwise know its surroundings.
Sense, location, and...
Sense and avoid. So SLAM sort of simultaneous location and mapping.
Simultaneous location and mapping.
So that's exactly what you do. You not only sort of look around you and get a sense of the room, but you also can find out where you are in the room, which dictates the path.
All right, so let's look at Skycatch for a second. Christian, come on over.
Yes.
Now, you're a former Navy SEAL.
Well,
Oh, I'm sorry, Navy SEAL trainee.
trainee, yeah,
So you rang the bell.
I did.
What happened? Tell us that story.
I did. Actually, I tried out multiple times. When I finally got in, I was there for a couple months, right before Hell Week. I got injured really bad, and I was hospitalized, and I was forced basically to ring the bell.
For people who don't know, ringing the bell means?
You quit, basically, yeah. You basically give up your opportunity to become a Navy SEAL. Yeah.
And that was the dream of your life, to be a Navy SEAL?
That was the dream of my life at that point.
What was that moment like when you had no choice because your knees were so incapacitated, the doctors say you can't continue? Tell me that moment when you hit the bell.
So my choices were re-up in the military, do another 4 years, and go back class up to the next class, or just leave the training completely. And so when I chose that, it was just it was really bad for me, because it was basically, I saw myself in the middle of nowhere doing satellites, talking to satellites and doing a lot of the computing stuff. And to not see that in front of you is really tough.
Yeah.
Yeah.
But you decided to start a company shortly thereafter.
Yes. So
tell us about this company, Skycatch, and what are we seeing here?
So Chris Anderson has done an incredible job at making these guys really fully autonomous in the air.
Yeah.
Follow GPS, go to location, take a photo. What we've done is remove the friction on the other side, which is swapping batteries, getting that data out to the cloud, charging the battery. That's basically what we do.
Okay, so a drone that you've built is a specialized drone here will land on this? This is where the drone lives?
Exactly. So the drone autonomously land on top of the ground station. It'll move it so that it aligns itself with the arm.
Okay.
It'll take the battery out.
Can we see that?
Yeah.
Let's see that,
Let's give it a try.
Now, where are you at? Is this the first prototype?
This is called Evolution 1.
Evolution 1.
This year is all Evolution era. Evolution 1, Evolution 2. Evolution 2 will have a fully autonomous casing. So it'll open up by itself. It'll close by itself. Evolution 3 will be...
The hard case will open by itself,
right,
essentially.
Absolutely.
So you put this in the middle of a crop or the middle of a field somewhere,
Right.
and then remotely you could open the case.
Right. So you can be in New York or you can be anywhere and say, I want some data in this area. And you can get ground truth, immediate data in real time.
Okay, so here we have the drone is resting in its home, its nest, if you will.
Right.
And it lands in here. It's sort of like a volcano or something.
Right,
and
the cone.
The cone. It lands in the cone.
Right.
And then what's going on in here?
So first of all, the UAV uses a camera to land itself using computer vision.
Okay.
And it also uses a directional microwave beam with receivers on each arm to guide itself down to the ground station. So that's very effective. And then what's happening now is looking for a new let's see.
So these are batteries here in these cases. Yeah. So this is like this is where all the battery packs charge. How long does a battery last on one of these now?
Just about. I mean, we got it tuned to last about 20 to 25 minutes.
20 to 25 minutes.
Yeah,
okay.
It really comes down to the battery, the type of motors, the propellers. You actually have to do a lot of work to make sure that you tune all of it together.
And so, a normal person, if you wanted to do crop dusting or whatever, and you wanted to go out okay, here we go. So it's moving, and what's happening here? The drone is spinning for some reason?
Yeah, so as soon as it lands, the robot basically adjusts the UAV so that it can
Oh, look, it's going to get the battery.
Right, so it's going to go in and pull the battery out.
Wow. So that is the issue, is the battery doesn't last that long, and a human has to be involved in flying it.
Right, and also the data. So when you collect a lot of the data, you want to have that data available to you right away. So ground station, on all the places that we're working with, like we work with mining companies, construction firms, all of them are fully wired typically. So some of the deployments are usually fully connected in terms of bandwidth to the ground station, and the battery itself has an SD card.
Oh, the SD card's in the battery.
Right.
So it's taking that out, it puts it back into charge,
Right.
rotates, takes another battery up,
Right.
and then it can go do another mission.
Can you go out and do another mission? Right.
Chris, did you ever think somebody would build something like this when you were building that little circuit board?
I saw sort of science fiction portrayals of this and thought, someday that would be awesome. And then Chris just comes along and does it.
Yeah. I mean, and this is part of your strategy to go open source and say, hey, we're not going to own everything.
Yeah.
Is what really enables another company to do this, because you couldn't have done it without his enabling technology, and you don't have the time to do this.
Right.
There are an infinite number of vertical applications, and this is 1984 to the PC. We've got the PC. What's it for? We're going to need developers to figure that out. And the great thing about so think of like maybe the iPhone. The iPhone was a great phone, web, email, and then came the App Store. And we're at the App Store moment for drones. This is a great example of an application that is a perfect vertical specialty for a company.
What will this cost a company? I mean, we're here, this is $750. This is a more industrial version, it looks like. What would it cost a company to put one of these out and survey, 10 times a day, the mine?
Yeah, so just to give you an example, some of these companies we're talking to on the mining industry, they're spending about $300K on equipment just to do surveying of stockpiles. Mm-hmm. Now, that's just one purpose. Now I load it up. Now it's ready to take off and do a mission. So we're charging for multiple uses. We're charging upwards in the hundreds of thousands of dollars for the full solution, which includes what we call the autonomous data retrieval solution, and also all the dashboards and the data computer vision side of things.
Do we envision a time when every home has something like this built into the attic, and if you're not home and you want to see what's going on, or you want a security system, it just flies a routine mission around the neighborhood to check out what's going on? Very
likely that you'll see these guys deploy in cities, neighborhood watch, and things like that. We've gotten all sorts of different types of inbounds that are with very creative different usage. Parking lot security, car dealership to go check on cars to see if they're available, all sorts of different things people have reached out to us for.
How rugged do you think this would be? So if this was the Amazon or something, and you had a nice hilltop and you wanted to just monitor what was going on in the rainforest for conservation reasons or whatever, studies, could you just leave this parked out there for a couple of years and have it just...
That's the goal. So our next era of ground stations, we call them Discovery era. Discovery 3 will be fully autonomous, and it's basically one of our clients wants to have these deploy in Chile and then inspect and do ground truth and surveillance in all of their operations.
It's amazing. And both of your companies are venture-backed now?
Yes.
When you came to the venture capitalists, I don't know how many years ago, did they understand this and think it was a market, or did they just laugh you out of the room?
It's interesting. We did our Series A at the end of 2012, and there, when we got no, which wasn't often, but when we got no, it was like, oh, it's a hobby thing. There's not a real market there. 12 months later, it was so evident that it was a market that when we ever got no, it was there, well, we think it's going to be huge, but we're not sure you're going to win. So given the choice between those two problems, I will definitely choose it's a huge market, you've got to win, rather than we're not sure there's a market at all. So yeah, I think at this point, we're in a bit of a drone bubble, actually, right now. There's just incredible excitement about this. People, you start to see them on, in parks, the Amazon announcement, which people recognize some of our technology in that as well.
Was that Amazon announcement just PR to get Jeff? Not that anybody would ever accuse Jeff of showmanship, but was that a PR move? Do they have any intention of doing something like that?
Amazon's serious. They are really doing it. Now, whether they actually deliver to the home, as opposed to maybe warehouse to warehouse initially, remains to be seen.
Now, what about the legality of flying these, right? Like, everybody's concerned about flying over people. Will these be allowed to fly over our cities, our towns, and under what circumstance? What do you think is the reasonable societal compromise with these?
Sure. Well, today we're flying under FAA regs, which says that for consumer use, when you're not charging for it, you have to stay under 400 feet within visual line of sight, which is about a mile, and away from built-up areas. So you cannot fly legally over a town or people's houses. Commercial use actually is not even allowed in the United States right now, but there's a rulemaking process that will by 2016 or so. Outside the United States, the rules are somewhat different, but in general, it's every country or every developed country has a rule about not flying over people's houses. Not just for privacy, although that's a real issue, but also for safety purposes. So I think that people get very excited about the notion of drone delivery, taco copters, et cetera. That's the last thing you want to do is like spinning blades and people. You want to keep them as far away from them as each other as possible.
What's the biggest accident? We tried to get this out of the pocket drones guys yesterday. They wouldn't really say, but somebody's kept a list of all the accidents. Yeah. Nobody's been killed by a drone yet?
Well, people have been killed by radio control helicopters and planes. Absolutely, yeah. Some guy in Brooklyn was killed last year by a radio control helicopter, not a drone. Drones are typically defined as capable of full autonomy.
Right.
But people have had RC helicopters and planes for 50 years, and these things can be dangerous.
And so, what is the application we'll see? I know we saw real estate people selling this, to do flyovers of mansions and estates to sell them. Is that business is now illegal?
Well, it's a little bit in the gray zone. First of all, these are FAA guidelines, not a law. Second of all, private land, resolves some of the issues. We're working on something we call one-button building mapper, which is sort of you point to the building on Google Maps, press a button, and the copter goes around the building twice, uploads the data to something like Autodesk's 123D Catch, which is a stitching application, creates a 3D model. That's something people want, golf courses or high-end real estate. Right now, if you don't charge for it, if you're using your own vehicle on your own property, it's probably okay. If someone's charging for the service, then it probably is considered commercial use. Yeah.
Christian and Chris, this is amazing technology, and it's super fascinating. Thanks for sharing with us. Big round of applause for Chris and Christian. Well done. It's incredible. Thanks for coming out and showing it. And everybody gets, what was this one called, the iris?
Iris.
Yeah, so there's an iris under everybody's seat. Thank you, Chris. That was extremely generous. Maybe in a couple years.